Today, we will discuss a very interesting aspect of geochemistry. As everybody knows, usually we cannot pinpoint the depth of the signal that we are discovering on surface. But there is a method that is very common in Russia. When I was a student there, it was given to me like, normal information, like 2 + 2 is 4. And it was called determining the erosional level. Basically, using geochemistry, we can determine the position of the erosional level with respect to the ore body. And therefore, using this method, we can have an idea of how deep our mineralization source is, or also is a very good method to categorize our anomalies and define where are we going to study first. Here, this table that, as you can see, you can find in following this link here, this DOI. We have an example of a raw data, normal data converted all to part per billions. Okay, so this is our normal data. The method that we are talking about is called the erosional level. And I call this the original. This is the one I learned when I was a student. And it basically, the theory says that when you have the formation of the deposit, there is always a group of elements that will tend to form on top of the deposit because they are more mobile, and those are called supra elements. And there will be a group of elements that tend to form below the ore body, and those are called infra elements. Examples of supra elements are mercury, barium, silver, and others. Examples of infra elements are cobalt, nickel, chrome, etc. So basically, if you make a coefficient dividing the supra elements by the infra elements, and you get that coefficient gets a value that is very, very big, that means that the erosional level has not yet reached the ore body. That is a very good thing. But if you get an erosional level, a coefficient that is very small or negative, that means that the erosional level has already reached this part. So even though that you may have an anomaly, this is a residual anomaly because the ore body has been already eroded. Okay, so there is plenty of reference about this method. Here you can see some of them. Because many people ask me, well, where can I find more about this thing? You studied at the university, but want to read it. So these are some of the books that talk about this method in details. And it also offers a list of from the most supra to the most infra elements that you can use. So how do you calculate the erosional level? It's very simple. Let's say we will use here 3 elements, like supra elements like barium, iode, zinc, and 3 elements infra elements like cobalt, nickel, and chrome. The first step is to standardize all these values so the difference in their concentration doesn't affect us. The formula for standardizing, you can see it here, is standardized by the mean and the standard deviation for each element. Once we have standardized all the data, then the formula is very simple. We take the integral part of the sum of all the supra divided by the sum of all the infras, and we get these columns here. For example, that -1 means that we are down here. That 4 means that we are up here. Okay, a value of zeros, ones, etc. Maybe we are already at the level of the ore body. In any case, the negative values are the ones to be avoided. Now, this is the way I was taught this method. But later on, I realized that there is a factor, a physical factor that is not included in this formula. This is basically a pure geochemical formula. And the factor that is not included here is the elevation. And as everybody knows, erosion has more force on high elevation than on lower elevation. So I added to the formula a coefficient, which was the elevation, okay? And again, it's the same method. We standardize everything, and then the formula will be the same, but multiply by this coefficient here, the elevation coefficient. And as I did some graphics and I saw, okay, I'm getting a much better idea of the erosional level because I'm taking into consideration the elevation. Well, the next step was to do a little comparison of all of these methods. Like this is a normal method, this is a normal method, but multiplied by the elevation. And then I just standardize those two columns. As you can see here, that is the erosional level, the normal one, pure geochemically. This is the erosional level standardized. Okay, the same thing, but standardized. Then this is the erosional level, taking into consideration the elevation, and the same thing, standardized. And finally, I added both values and direct added and the absolute value of that sum. And as you can see, this last column, the absolute value of the sum of both erosional levels, give us the best result for mapping the erosional level. So this is how we get this column. And I'm going to show you now our data, the data that we have been using. This is, again, you can check this database here at this DOI. You can download it from there. And I have already here the column of erosion or erosional level. And we're going to use now Surfer to process this erosional column. So we go to Surfer. That was our last map. We start by defining the variogram for the erosional level. So grid, variograms, new variograms. We select our data. We select here erosional level. And we get this variogram, which is basically, well, the straight line will probably do. Okay, let's do our usual cleaning. Yeah, that line is very good, but let's try to do the autofit and see if it gives us, oh, yes, it gives us a much better line. That will be the variogram for the erosional level. So as usual, I will take my cut tool, cut this section, copy, and paste. And I will save it as variogram elevation. I have it done previously, so I will not do it again. And then again, we go to grid data. Because we have faults, and the faults should affect the erosional level too, we will use invert distance to a power, and select the erosional level. The anisotropy, the ratio is 1:242. The anisotropy, the angle is 90. Faults, use the fault, and then we can skip to the end, and it will be called erosional level. And to save some time, I'm gonna click on create a new map, and it will be a contour map. So I click finalize, accept. I will take off the variogram. So this is our map for the erosional level. So as I mentioned, we need to figure out which are the values that are low So again, we click on the map, we go to levels, click on advanced, edit levels. You can see all the negative here. So I would start by deleting everything that is bigger than 1. Okay. And then I will delete everything that is between 10 and -1, because I really need to know the lower level of the erosion. So I will put this as a blank. I will put this as a grid with no opacity. I use usually the color brown for this. Okay. I don't need labels for that. I don't need a line for this. And press apply. And I can, okay. And then I need to put the fill contours. And these are the areas that have been eroded in our map. So if I get an anomaly somewhere here, I will test the latest one. This is a way of categorizing the anomalies into more important or more prospective and less prospective. As we did the last time, we can just take this copy and go back to our map and paste it. Just drag this down here. Okay. You can see all the erosional levels here. And that will be the base map that we will be using for our representation of the anomalies, which will be the subject of our next webinar. So here you are, erosional levels. I hope you find this video very useful. Until next time, enjoy.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.